Hello friends, in this video we'll study motional EMF and we will be taking rotational motion cases. Okay, when the rod is rotating, ring is rotating, or any rigid body which is rotating, and studying their motional EMF or EMF caused due to rotational motion of the object. So let's start with the first one. A rod of length L is rotating with angular velocity omega about one of its ends such that axis of rotation is parallel to the uniform external magnetic field which is into the plane of paper. We have to find electric field that is induced as a function of x. X is nothing but the distance from this axis of rotation, and take a small element obviously of length dx. Okay, this is small length dx, and EMF induced as a function of x. Draw their graphs also. So let's draw this dx by enlarging it. Let's say this is dx. It is moving with the velocity as it is at a distance x, so the velocity will be omega x, and magnetic field is into the plane of paper. So we can say by using V cross B, this will be positive and this will be negative, or we can say V cross B is coming towards the axis. Okay, V cross B if towards the axis, then axis is that the highest potential, and the farthest point from the axis will be lowest potential. We can say potential is gradually decreasing as field is always towards the axis. Okay, sorry, electric field will be away from the axis. Okay, as positive terminal is here, negative is here, so electric field has to be in this direction. Okay, so talking about electric field at this point, we can say electric field or EMF induced in small dx. So EMF induced will be V is x omega into L is dx. That small induced EMF can be written as electric field into dx. So electric field will come out to be Vx omega. Electric field strength increases with distance, and EMF induced. To find EMF induced, just integrate it. dE is equal to small EMF induced is equal to Vx omega dx, and integrating with 0 to L or 0 to any amount x. Let's say we have to find the potential difference between these 2 points. It will come out to V omega x square by 2. Okay, so EMF as a function of x, EMF induced as a function of x is this. We can draw their graphs. We can say electric field increases as we move away from the axis, and the graph is parabolic for EMF induced. As we know, this is x square function, so it will be like this. In this case, parabola is opening up outward because it should be actually opening. As axis has maximum potential, this should not be the parabola. As we move away from the axis, potential is decreasing, so it should be a downward opening parabola. This is just the magnitude of EMF induced, and if we follow its trend, it is decreasing in value. Okay, so it is the EMF induced or delta V which is decreasing with this, so it is as a function of x. Okay, I'll further explain this type of graphs in the next part of the video. So point to be remembered that EMF induced versus x is a parabolic function, and electric field versus x is a linear function. V cross B is the direction of highest potential. If it is towards the axis, then axis will be at highest potential, and if it is away from the axis will be at lowest potential. Always try to find out the potential of axis. Either it will be maximum or minimum. Okay, so these are the certain observations. These are very, very important points. Let's start with the first one. Potential difference between 2 points at a distance x1 and x2 from the axis is nothing but p omega x2 square minus x1 square. I have taken mod because I'm not giving any polarity to this. Polarity will be given using the direction of v cross b, okay, or which point is at higher potential. So the value of potential difference is p omega by 2 x1 square minus x2 square. Field at a distance x from the axis is p omega x, so field at axis will be 0. E at axis is obviously 0. Axis rotation will be either at highest or at lowest potential. How to find out whether it is highest or lowest? Do this p cross b, velocity at any point, whether it is on the right or left of the axis, it doesn't matter. So v cross b is, if v cross b is towards the axis, then axis is at the highest potential, and if it is away from the axis, obviously axis will be at its lowest potential. 2 points which are equidistant from the axis, no matter where they are, they should be just equidistant. Okay, they may be, let's say if this is a ring and all these points are equidistant from this axis of rotation, so they will have same potential. Okay, because for potential difference only the distance from axis is required. Draw these graphs. X is the distance from the axis. I have already drawn this graph. V cross B is towards the axis. Okay, if V cross B is towards the axis, obviously axis will be at highest potential. So as we move away from the axis, potential should decrease and it should be a parabolic function. And when V cross B is from away from the axis, axis will be at lowest potential. So as we move away from the axis, potential should increase. Okay, these are the points should be remembered, and in the next video I am going to solve very important questions related to this. Okay.